Geologist Randall Carlson asserts that the enigmatic planet Nibiru is real and is on a collision course with Earth, following years of extensive research and speculation. Carlson's discoveries cast new light on ancient catastrophic events. But what evidence supports the existence of this rogue planet, and how does it relate to Earth's tumultuous past? Join us as we unravel this extraordinary story and examine the potential impact of Nibiru's return on our planet's future. Exploring Earth's past, geologist Randall Carlson unveils the secrets behind some of our planet's most devastating events. His comprehensive research delves into Earth's geological history, uncovering evidence of massive floods and their monumental effects on our world. But what implications do these findings have for us today? Could these cataclysmic events be part of a recurring cycle? Carlson's journey begins with landscapes scarred by ancient floods. He identifies signs of colossal water movements that far exceed the scope of any modern disaster. These floods, he argues, were not just local phenomena but were continental in scale, ultimately reshaping the Earth's surface. The evidence lies in the geological formations we observe today: gigantic canyons, boulders transported hundreds of miles, and layers of sediment that tell a story of overwhelming force. But what caused these floods? Carlson points to several potential triggers, including comet impacts and rapid ice melts. He presents compelling data suggesting a series of cometary bombardments, each releasing enough energy to melt ice caps and unleash torrents of water across continents. This theory is supported by a pattern of geological markers that align with known periods of sudden climate change. Carlson's belief in recurring cataclysmic events is rooted in the concept of cycles. He proposes that Earth experiences these devastating floods at regular intervals. This idea challenges the conventional view of Earth's history as a steady, gradual process. Instead, Carlson paints a picture of a planet subject to periodic upheavals, where stability is the exception rather than the rule. But how do we know these events are part of a cycle? Carlson's research highlights several periods of dramatic climate shifts, each marked by signs of massive flooding. These periods coincide with changes in Earth's orbit, shifts in solar activity, and other astronomical phenomena. By studying the past, Carlson believes we can predict future cataclysms and prepare for their impact. This raises a crucial question: are we due for another cataclysm? Carlson's work suggests that understanding these cycles is key to our survival. If we can recognize the signs of an impending disaster, we can take steps to mitigate its effects. Another theory that ties into these ideas is the Nibiru cataclysm theory, one of the most captivating and controversial theories. This theory posits the existence of a rogue planet, Nibiru, whose periodic passage through our solar system brings about catastrophic events on Earth. The Nibiru cataclysm theory traces its roots to the interpretations of ancient Sumerian texts by Zakaria Sitchin, an Azerbaijani-born author who gained notoriety in the 1970s with his book, The 12th Planet. In his work, Sitchin translated and interpreted cuneiform tablets from ancient Mesopotamia, proposing that these texts reveal the existence of Nibiru. According to Sitchin, the Sumerians had detailed knowledge of this mysterious planet and its profound influence on Earth. Central to Sitchin's theory is the concept of Nibiru's elongated orbit, which he calculated to be approximately 3,600 years. Unlike the well-known planets of our solar system, which follow relatively stable circular orbits, Nibiru's path is highly eccentric, taking it far beyond Pluto at its farthest from the Sun and bringing it perilously close to Earth at its return. This infrequent but devastating approach, Sitchin argued, is responsible for periodic cataclysms throughout Earth's history. But what exactly happens when Nibiru nears our planet? According to the theory, Nibiru's massive size and gravitational pull could trigger a series of catastrophic events. These might include severe earthquakes, volcanic eruptions, and dramatic climate shifts, all stemming from the gravitational disruptions caused by the planet's proximity. Additionally, Nibiru could potentially dislodge comets and asteroids from their orbits, sending them hurtling toward Earth and causing further devastation. Sitchin's interpretations extend beyond mere laws of physics. He delves into the mythological and cultural significance of Nibiru in ancient texts. In Sumerian mythology, Nibiru is often associated with the god Marduk, a powerful deity who represents chaos and creation. Sitchin suggested that the myths surrounding Marduk and Nibiru were not just symbolic stories but actual historical records of extraterrestrial encounters and cosmic events. One of the most controversial aspects of Sitchin's work is his claim that the ancient Sumerians were in contact with an advanced race of beings from Nibiru known as the Anunnaki. According to Sitchin, these extraterrestrial visitors came to Earth approximately 450,000 years ago seeking to mine gold and other resources. The Anunnaki, he proposed, genetically engineered early humans to serve as their labor force, a notion that intertwines ancient mythology with modern pseudoscience. Despite the intriguing narrative, the Nibiru cataclysm theory has faced significant criticism from the scientific community. Mainstream astronomers and astrophysicists argue that there is no empirical evidence to support the existence of Nibiru. Extensive sky surveys and observations have failed to detect any rogue planet on a collision course with Earth. Moreover, the gravitational effects such a planet would have on the known bodies in our solar system would be noticeable and measurable, yet none have been observed. But what are the scientific community's thoughts on the planet Nibiru and its potential danger to Earth? NASA and mainstream scientific communities maintain a clear and consistent stance. There is no concrete evidence to support the existence of such a planet within our solar system. This position is based on extensive astronomical observations and research, which have yet to reveal any planetary body in space that fits the description of Nibiru. NASA's primary tool for surveying the sky is the Wide Field Infrared Survey Explorer, or WISE, which scans the cosmos in infrared light. Since its launch in 2009, WISE has mapped the sky multiple times, searching for objects ranging from near-Earth asteroids to distant galaxies. One of its missions was to identify any large unknown planets that might exist within our solar system, particularly those beyond the orbit of Neptune. If a planet like Nibiru existed and were on a collision course with Earth, it would have been detected by WISE or other observatories. The concept of a planet with a highly elongated orbit that takes 3,600 years to complete a revolution around the Sun poses several significant scientific challenges. Such an orbit would be highly unstable over long periods, making it unlikely for a planet to maintain this path without being disturbed by the gravitational influences of other planets. Mainstream scientists argue that the dynamics of our solar system, governed by the laws of mechanics, do not support the feasibility of such an orbit. The methods and instruments used in modern astronomy further emphasize the lack of evidence for Nibiru. Telescopes around the world, both ground-based and space-based, are constantly monitoring the skies. These observatories employ a variety of wavelengths, from visible light to radio waves, to capture a comprehensive picture of our solar system and beyond. The meticulous data collected from these instruments have allowed astronomers to map the positions and movements of countless objects in space with high precision. In such a thoroughly monitored environment, the existence of an undiscovered planet of significant size is highly improbable. Additionally, scientific consensus is built on peer-reviewed research and empirical evidence. Theories are rigorously tested and validated through experiments and observations. In contrast, the Nibiru theory largely stems from interpretations of ancient texts and unverified claims. Zecharia Sitchin, who popularized the Nibiru cataclysm theory, based his conclusions on his interpretations of Sumerian mythology and astronomical knowledge. While Sitchin's work has garnered attention and a following, it has not withstood the scrutiny of the scientific method. Mainstream scholars and scientists criticize Sitchin's translations and interpretations as inaccurate and not supported by archaeological evidence. The distinction between speculative theories and scientific consensus is crucial. Scientific theories are formulated based on observable phenomena and must be falsifiable, that is, they can be proven wrong through evidence. Theories such as the Big Bang, evolution, and general relativity have all been subjected to extensive testing and have consistently been supported by empirical data. In contrast, speculative theories like the Nibiru cataclysm lack this foundation of verifiable evidence. However, there is evidence that supports Carlson's theories. Randall Carlson's theory of cataclysmic events is supported by geological and astronomical evidence. By examining patterns in the geological record, Carlson argues for the existence of periodic large-scale cataclysms that have dramatically reshaped our planet's surface and impacted human civilization. One of the primary pieces of geological evidence supporting Carlson's theory is the presence of widespread large-scale flood deposits. These deposits, found in regions like the Pacific Northwest of the United States, suggest that massive floods far beyond anything witnessed in recorded history have occurred repeatedly. These megafloods are believed to be the result of sudden catastrophic releases of water, possibly from glacial lakes bursting their confines. The resulting torrents carved out vast canyons and reshaped entire landscapes in a matter of days, leaving behind distinct geological markers that scientists can study. In addition to flood evidence, there is compelling data pointing to periodic comet impacts. Carlson and other researchers have identified layers of sediment rich in iridium and other extraterrestrial elements that correspond to known extinction events. One of the most famous examples is the Chicxulub impact, which is widely believed to have caused the mass extinction that wiped out the dinosaurs 66 million years ago. Similar evidence has been found for other lesser-known impacts, suggesting a pattern of cometary bombardment that aligns with Carlson's hypothesis of recurring cataclysms. Volcanic activity also plays a significant role in Carlson's theory. Supervolcanoes, such as Yellowstone, have erupted with cataclysmic force multiple times in Earth's history. These eruptions can spew vast amounts of ash and gases into the atmosphere, leading to dramatic climate shifts known as volcanic winters. Geological records of these events show layers of volcanic ash spread over large areas, indicating eruptions that were powerful enough to affect global climate and, consequently, human societies. Ice Age cycles add another layer of complexity to Carlson's theory. The Earth has gone through multiple ice ages characterized by the advance and retreat of massive ice sheets. These cycles are driven by various factors, including changes in Earth's orbit and axial tilt, as well as variations in solar output. The transitions between ice ages and warmer interglacial periods are often marked by abrupt climate changes, which can trigger widespread environmental upheaval and significant challenges for any civilizations that existed at those times. Speculating on how Nibiru could fit into this pattern of cataclysms, one could imagine that such a rogue planet, if it exists, might periodically enter the inner solar system and exert significant gravitational forces on Earth. These forces could potentially trigger seismic and volcanic activity, disturb Earth's orbit, and even influence the trajectories of comets and asteroids, increasing the likelihood of impacts. The hypothesized 3,600-year orbit of Nibiru might coincide with some of the periodic cataclysmic events recorded in Earth's geological history, suggesting a possible extraterrestrial catalyst for these recurring disasters. The ancient texts and myths that mention Nibiru often describe dramatic upheavals and divine interventions, which could be interpreted as cultural memories of real cataclysmic events. If Nibiru had been responsible for periodic disruptions, it might have left a permanent mark on the collective consciousness of ancient civilizations, which is encoded in their legends and lore. But that's not all. Carlson's exploration of sacred geometry and ancient wisdom is a fascinating journey into the intersection of mathematics, astronomy, and ancient architectural marvels. He delves into the idea that ancient civilizations possessed incredible knowledge encoded within their monumental structures. This knowledge, he states, is mathematical, astronomical, and metaphysical, reflecting a sophisticated understanding of the universe and its inherent order. Sacred geometry refers to the study of geometric shapes and proportions that are considered sacred or divine. These shapes, often found in nature, are believed to represent fundamental aspects of the universe. Carlson suggests that ancient structures, from the pyramids of Egypt to Stonehenge, embody these principles of sacred geometry. These structures are not just architectural feats but also repositories of advanced knowledge about the universe and the underlying order of reality. One of the central ideas of Carlson's theory is that ancient builders used specific ratios and geometric patterns to encode important information. For instance, the Great Pyramid of Giza is often cited as a prime example. Its dimensions are said to incorporate the mathematical constants pi and the golden ratio, which are essential in understanding circular geometry and aesthetics. The precision with which these constants appear in the pyramid's design suggests that the builders had an advanced understanding of mathematics beyond mere construction techniques. Carlson extends this idea to other ancient sites around the world. He argues that many of these structures were deliberately aligned with celestial bodies and significant astronomical events. For example, the pyramids of Teotihuacan in Mexico exhibit precise astronomical alignments, reflecting the builder's sophisticated grasp of the movements of the stars and planets. Beyond individual structures, Carlson introduces the concept of a global grid of sacred sites connected through energy lines, often referred to as ley lines. This theory states that ancient civilizations across the globe built their monumental structures on these energy lines to harness the Earth's natural energies. These lines are thought to form a network that connects various sacred sites, creating a global pattern of energy flow that ancient peoples tapped into for spiritual, healing, or knowledge-enhancing purposes. The idea of ley lines suggests that there was a shared, perhaps even universal, understanding of the Earth's energies among ancient civilizations. This understanding allowed them to place their structures strategically to maximize the beneficial effects of these energies. Carlson points to the striking alignments between sites like the Great Pyramid, Stonehenge, Machu Picchu, and the Nazca lines as evidence of this global network. He argues that these alignments were not coincidental but were the result of deliberate planning based on a deep knowledge of the Earth's energy grid. This perspective invites us to reconsider the capabilities and intentions of ancient civilizations. Rather than viewing them as primitive or solely focused on survival, Carlson's theory portrays them as highly advanced in their understanding of the universe. Their monuments were not just functional but also held deep symbolic meaning and knowledge. But what events in Earth's history could have driven these ancient societies to such a deep understanding and expression? One such period of dramatic change and challenge is the Younger Dryas. The Younger Dryas period, named after the resilient Dryas octopetala flower, marks a fascinating chapter in Earth's climatic history. Occurring roughly 12,800 to 11,500 years ago, this period represented a dramatic climatic shift. The Earth was transitioning from the cold late Pleistocene to the warmer Holocene, but instead of a smooth transition, there was an abrupt return to glacial conditions. Temperatures plummeted by approximately 2 to 6 degrees Celsius in a short span, leading to significant ecological and environmental changes. While the comet impact hypothesis is popular, other theories also attempt to explain the sudden climate shifts during the Younger Dryas. One prominent theory involves changes in ocean currents. Specifically, the theory suggests that the influx of freshwater from melting glaciers disrupted the Atlantic meridional overturning circulation. This crucial ocean current helps regulate climate by transporting warm water from the tropics to the North Atlantic. When large amounts of glacial meltwater entered the North Atlantic, it potentially disrupted this circulation, leading to rapid cooling. Randall Carlson's broader perspective on Earth's climate history goes beyond the Younger Dryas. He suggests that Earth's climate system is dynamic and subject to sudden changes, not just gradual shifts. Carlson's research highlights periods like the Ballingallorod warming before the Younger Dryas, which also saw rapid climatic changes. How far is Carlson's knowledge influenced by ancient civilizations' knowledge of astronomy and cataclysmic events? Ancient civilizations were remarkably advanced in their understanding of astronomy long before the invention of telescopes and modern scientific methods. Ancient peoples across the globe studied the stars and developed sophisticated systems to track celestial movements. They used this knowledge not only for practical purposes such as agriculture and navigation but also for ceremonial and religious activities. How did they achieve such an intricate understanding of the cosmos without modern technology? The answers lie in their keen observations and innovative approaches to integrating astronomy into their daily lives. The Maya civilization, for instance, was renowned for its astronomical expertise. One of their most impressive observatories is El Caracol, located in the ancient city of Chichen Itza. This structure, also known as the snail due to its spiral staircase, was meticulously designed to observe celestial events. The Maya used El Caracol to track the movements of the sun, moon, and planets, aligning their architectural features with significant astronomical events. The Maya calendar is another testament to their astronomical prowess. It consisted of several interlocking cycles, including the Tzolk'in, a 260-day ceremonial calendar, and the Hab, a 365-day solar calendar. The combination of these cycles created the calendar round, a 52-year period which the Maya believed was significant for both timekeeping and predicting astronomical events. How did the Maya achieve such accuracy? Their precise observations and complex mathematical calculations enabled them to predict solar and lunar eclipses and other celestial phenomena with remarkable accuracy. Moving to another part of the world, the ancient Egyptians also demonstrated a deep understanding of astronomy. The Great Pyramid of Giza, one of their most iconic structures, is aligned with the stars in Orion's belt. This alignment was not accidental, it reflects the Egyptians' belief in the connection between the heavens and their pharaohs. They believed that the pharaohs would join the stars in the afterlife, and the pyramids served as a gateway. The Egyptians used their knowledge of the stars for more than just religious purposes. They also relied on astronomy for practical matters, such as determining the annual flooding of the Nile River, which was crucial for agriculture. The heliacal rising of the star Sirius, known as Sopdet in ancient Egypt, signaled the start of the flood season. This precise timing helped the Egyptians plan their agricultural activities, ensuring the survival and prosperity of their civilization. But the Maya and Egyptians were not alone in their astronomical endeavors. Across the world, various ancient cultures integrated astronomical observations into their daily life and architecture. For example, Stonehenge in England is aligned with the solstices, marking the longest and shortest days of the year. This alignment suggests that Stonehenge was used for ceremonial purposes related to the solar cycles. Similarly, the ancient Chinese developed detailed star maps and calendars based on their observations of the night sky. They used this knowledge to guide agricultural practices and predict celestial events. The Babylonians, too, made significant contributions to astronomy, developing a lunar calendar and recording celestial phenomena with impressive accuracy. But that's not all. Modern science has built on these ancient foundations and made new discoveries. One of the most exciting developments in planetary science is the discovery of exoplanets, which are planets orbiting stars outside our solar system. Since the first confirmed detection in 1992, thousands of exoplanets have been identified, revealing a vast and diverse array of planetary systems. These discoveries have been made possible by techniques such as the transit method, where scientists observe the dimming of a star's light as a planet passes in front of it, and the radial velocity method, which detects the wobble in a star's motion caused by the gravitational pull of an orbiting planet. Exoplanets come in many forms, from gas giants larger than Jupiter to rocky planets similar in size to Earth. Studying these planets provides valuable insights into the processes that shape planetary systems. For instance, the discovery of hot Jupiters, giant planets that orbit very close to their stars, has challenged existing models of planetary formation and migration. Moreover, by analyzing the atmospheres of exoplanets, scientists can assess their potential for supporting life, expanding our understanding of habitability. The techniques used to find exoplanets are also applicable in the search for hypothetical planets within our own solar system, such as the elusive planet 9. By observing the gravitational effects on known objects and using advanced telescopes to scan the skies, astronomers hope to uncover new planets that could explain certain anomalies in our solar system structure. Beyond the well-known planets of our solar system lie the Kuiper Belt and the Oort cloud, two regions that are rich with icy bodies and remnants from the solar system's formation. The Kuiper Belt, located just beyond Neptune's orbit, is home to dwarf planets like Pluto and Eris, as well as countless smaller objects. These bodies are believed to be remnants from the early solar system, providing clues about its formation and evolution. The Oort cloud is a hypothetical spherical shell of icy objects that surrounds the solar system at a much greater distance. While no direct observations of the Oort cloud have been made, its existence is inferred from the behavior of long-period comets, which are thought to originate from this distant region. Theories suggest that the Oort cloud contains a vast number of objects, possibly even undiscovered planets, that have remained hidden due to their great distance from the Sun. Exploring these outer regions could reveal much about the early conditions of the solar system and the processes that govern planetary dynamics. It also raises the possibility of finding new planetary bodies that could provide further insights into the complexities of our cosmic neighborhood. The quest to explore the outer reaches of our solar system and beyond is driving the development of advanced missions and technologies. Upcoming missions, such as NASA's James Webb Space Telescope, are designed to look deeper into space with unprecedented clarity. This telescope will help identify new exoplanets and analyze their atmospheres, bringing us closer to answering fundamental questions about the potential for life elsewhere in the universe. In addition, missions like the European Space Agency's Gaia spacecraft are mapping the positions and motions of billions of stars, providing a detailed picture of our galaxy. These data sets are invaluable for tracking down elusive planets and understanding the structure and evolution of planetary systems. Advancements in propulsion technology, such as ion drives and solar sails, are also paving the way for more ambitious explorations. These technologies could enable faster and more efficient travel to distant regions of our solar system, making it possible to study the Kuiper Belt and the Oort cloud and even look for planets such as Nibiru in greater detail. Thank you for watching another episode of Space Trailway. While you are still here, click on any of the videos on your screen to see more mind-blowing content.